Please type in your questions using the chat box during the presentation. I will collect the questions and then read out the questions to the speakers at the end of their presentation. Now, first of all, let me quickly go through the schedule of today's webinar. I will firstly introduce two speakers for the opening addresses, Jingyi Wan from the CIGRE UK NGN and Professor Xiaoping Zhang from the University of Birmingham. And then after that, I will introduce our first keynote speaker, Dr. Rob Stephen, the president of the CIGRE. And then after that, I will introduce Adam Middleton, who is currently the chair of the CIGRE UK. And finally, I'll provide a brief closing remark. So now, I would like to introduce Jingyi Wan to give a welcome speech. Jingyi Wan is now the chair of the CIGRE UK NGN. She is a chartered engineer working as high voltage cable system specialist in Mott and MacDonald. Currently young member of CIGRE Working Group B170 on recommendations for the use and testing of optical fibers in submarine cable. So now, Jingyi, could you please start sharing your screen?
Hello, everyone. Sorry for the slightly technical issue here. So my name is Jingyi Wan. Thanks, Ian, for introduction. So what is CIGRE? CIGRE is a collaborative global community, and it has 15,000 professionals from over 90 countries. And I would like to also introduce you to the biggest event organized by CIGRE. It is the CIGRE Paris session, and it is a world-leading event for sharing power system expertise. CIGRE's knowledge program has 16 domains with more than 250 working groups, and the knowledge program lead to a congress called CIGRE Paris, happens every 2 years. This year it will be an e-session, and so it will be a very accessible way to have a taste of CIGRE Paris. And what is CIGRE NGN? CIGRE NGN is a professional network for engineers studying the early stage of their career, and I'm currently the chair of CIGRE UK NGN. We organize events for young members and also support young members to get involved in CIGRE activities. I would like to share some personal experience with you. The first event I've joined is the CIGRE UK Young Member Showcase in 2018. After the showcase, I received a sponsored ticket from CIGRE to joining the Paris session in 2018. And that is where I met Professor Zhang, who happened to be the next speaker. So what a coincidence. And in this year, I also led our team and delivered Young Member Showcase in University of Manchester. 3 nominated winners get the sponsored tickets for the coming up e-sessions. My closing remark will be, we want you to join us to the 2021 Young Member Showcase, and it will be a great opportunity. I will hand back to Ying. Thanks, Ying.
Thank you. Can you stop sharing your screen so I can?
Yeah. Can you stop me, or let me try?
Yes.
Yes,
that is excellent. Thank you, Jingyi, for the excellent and clear introduction of CIGRE and CIGRE UK NGN. And now I would like to introduce our second speaker for the opening address, Professor Xiaoping Zhang. Professor Zhang is currently chair in electrical power systems. He is director of Smart Grid Research Center and co-director of Birmingham Energy Storage Center at the University of Birmingham, UK. He is a member of CIGRE, a fellow of IET, and also a fellow of IEEE. Professor Zhang, could you please start, please? Thank you.
Thank you very much. Good morning, good afternoon, and good evening, ladies and gentlemen. My name is Xiaoping Zhang, Professor of Electrical Power System, Director of Smart Grid Research at Birmingham. It's my great pleasure to welcome two very distinguished speakers, Dr. Rob Stephen, President of CIGRE, and Mr. Adam Middleton, Chairman of CIGRE UK. Also, welcome all the participants who take the time to join this webinar today. Today's focus is about the global energy challenges and the transition towards sustainable low-carbon energy system, and also opportunities. At the beginning, also allow me to take the opportunity to say a few words about Birmingham's energy research. Energy at Birmingham is a vibrant community of more than 100 academic staff across the campus. And our research in energy include smart grids, HVDC artifacts, renewable energy control, energy storage, energy material, transport, and energy policies, as well as hundreds of research fellows, doctoral researchers, and taught MSc students. We collaborate with industry and institutions across the world. Birmingham has the critical mass and connection for students and academics to thrive in our intense energy research environment. Birmingham is a great city, very much related to the first industry energy revolution, symbolized by the first successful manufacture of steam engines in Birmingham by James Watt in 1776. Back to a few years ago, Birmingham was named as National Energy Capital. This would certainly encourage exciting low-carbon energy technology development as well as international collaborations. Energy challenges could not be tackled by a single country alone. International collaboration becomes essential for successful implementing the Paris Agreement on climate change. CIGRE is certainly an excellent platform to facilitate international collaborations, propose innovative smart grid solutions, and support individual career developments. Looking back, I personally benefited significantly from CIGRE network and technical support. Today, we are very delighted to have such an exciting opportunity to host this distinguished webinar. Finally, I appreciate the excellent works of CIGRE UK NGN team led by Jingyi Wan to make this webinar happen. Wish all of you have a very good time today. Stay safe and healthy. Thank you very much.
Thank you, Professor Zhang. So now it's my great honor to introduce our first keynote speaker, Dr. Rob Stephen. Dr. Rob Stephen is the president of CIGRE since 2016. He's past chairman of CIGRE Study Committee B2 on overhead lines and has held positions in CIGRE of special reporter and working group chairman, and has authored over 100 technical papers. He is a fellow of South African Institute of Electrical Engineers and was awarded the President's Award in 2016. The title of his presentation is Electricity Supply Systems of the Future, Challenges and Opportunities. Dr. Stephen, could you please share your screen?
Good afternoon, and thank you very much. What I'm going to cover today really is the electrical supply systems of the future, your challenges and opportunities. And this is work done through the CIGRE Technical Committee, which includes the study committees, which I'll cover so that you can understand a little bit of the structure of CIGRE and what work they're actually doing. So what is the purpose here when we're looking at power systems? And understanding the purpose of the power system is to supply electrical energy, satisfying the following requirements, which are obviously competing. One is reliability, security of supply, most economic solution, and best environmental protection. And often these are in conflict with one another. And this is really one part of the challenge. Just to give you a little bit about CIGRE, we're looking here at the technical activities. They're split into 16 study committees. I've been very involved in overhead lines, but there's also systems, components, telecommunications, materials, and so on. We have at any one time between around 230 to 250 working groups. And we, of those working groups, volunteers of about 3,800 experts globally are involved with the working groups. The working groups are there to solve problems for industry, which are relevant to the particular topic that they're looking at, such as overhead lines, substations, or whatever. Just to give you a little bit about the structure of CIGRE, which is often quite confusing. We have a General Assembly, which is all the members. We have an Administrative Council, which consists of the chairman of each of the 60 national committees, and the committee hosting this webinar today, of course, is the UK National Committee. So the chairman of that committee, Adam, is a member of the Administrative Council. Then we have the Administrative Council. You could consider really being the board, you could say. And then we have what's called the Steering Committee, which is like the EXCO, which consists of certain national committees and elected members. And then this area here, the sort of administrative area, comprises a central office in Paris, which is really small. It's under 20 people. And so the structure of CIGRE is actually very lean. Where all the work is actually done is within this area, the Technical Council, which consists of the 16 study committees and then the 230 working groups. And now your next generation network forms under the UK or under the particular national committee. They link, as do the Administrative Council members, together to form interesting topics, input into working groups, suggestions for the new working groups, etc. So by the one is that I would really encourage, if you aren't involved, is to get involved with a working group, either as a corresponding member or a full member. And you could really learn, because what's happening there is that all the experts from around the world are in fact discussing issues relating to their particular topic. Let's get on to the topic at hand. basically we can all understand that in the past we had generation on the one side, customer on the other side, power flow was in one direction. Now we get power flow coming in any direction and generations inserted at any points. And we've had, with the large rooftop PVs, of course, you can get from customer power flowing into the transmission network and through the transformers, of course, which create problems, because originally when they were installed, normally the power flow was from high voltage to medium or low voltage rather than the other way around. What CIGRE has done is it's highlighted 10 areas where in order to manage the new power systems, you actually have to look at all of these simultaneously. You can't just have one and then ignore the other. You have to understand the interaction between them and how they actually work. And I'll cover very quickly the 10 particular areas. The first one we're looking at really is your active distribution networks. Why it's called active, because it's got smart grids, got controls, it's got generation. And really, you can, I won't read all of this, but the presentations are available. What we're looking at, key challenges really is massive penetration of distributed generation units, control and coordination, especially if you have PVs with dumb inverters. How do you actually start controlling those without them hunting and whatever? There's also a very important one, which is evolution of markets and regulations. The different markets, in fact, create a very different power flows and different dynamics within the power system. And it's very important to understand that. And then also of course, ancillary services. How can we use distribution networks to provide ancillary services that is fault level voltage control, where you have this very inverter-based generation, which is, of course, doesn't provide you with any inertia, and various and stochastic generation and various fault levels. So what is the opportunities within this area is modeling, analysis and control of active networks. And then, of course, information exchange between transmission and distribution system operators. CIGRE has done a lot of work in this area. Of course, CIGRE is now distribution-based as well, goes from end to end. The next area to look at is dealing with this massive change of information. And the challenges here are architectures for information management, communication technologies, algorithms, and so on. And well, of course, cybersecurity and access control. Where are the opportunities? And these, when I call it opportunities, it's opportunities for further development, studies, working groups, getting involved. It's really into the cybersecurity area, and then new ICT architecture to accommodate new entities, energy and information. And of course, so one of these, of course, it would be the use of PMUs in real time and gathering enormous amounts of big data, where we could actually make use of this data for using analytics to really automate the system. The next area is integration of HVDC. It's not only HVDC, it's also MVDC, LVDC. And it's really integration of multi-feed networks into the AC networks at the HV level. Then the effects of power electronic penetration at all voltage levels, which includes reduced inertia, insufficient voltage support, low fault currents, and impact on power quality, especially with the low-cost inverters that might be coming in. So we need appropriate models, fault recovery of HVDC networks, standards and grid codes for HVDC grids. And CIGRE has done a lot of work on this as well, with the new brochures coming out on best practices for HVDC grid development that can actually be evaluated or transformed into grid codes. Opportunities here, development of appropriate control models, analysis and control of dynamic interactions between HVDC and PE systems. I think the reduction in the DC costs is resulting in a lot of high voltage DC systems becoming now a lot more viable. And the linking now between the AC and the DC is becoming more and more important. The next item which has been picked up, and I'll touch it a little bit again at the end, is really storage. And it's important to note here, of course, that storage in the world at the moment is mainly hydro, so it's mainly pump storage. Over 90% is pump storage. But the important thing to note is really the lithium-ion batteries linked to photovoltaic cells. And there again, the operation and use of storage in the modeling for steady state and dynamic simulations, cooperation with renewable systems in hybrid systems, and management of autonomous power systems. So really the challenges here are use of lithium ion type batteries, and then of course in the UK they're using liquid air storage as well, which also has a lot of potential, and I'll touch at the end on hydrogen. So storage is not only lithium ion batteries or battery storage, but the beauty about the battery is that it's been chemical, it's a very fast response. And we could model that to ensure that we can have a far more stable system. So the opportunities, the storage analytical models, where do you put the batteries and how big should they be and what problems will they solve? And then of course, new markets to produce and enhance flexibility. The market design around batteries has been something which has been going on for many years, mainly because they didn't want the utility to get a double benefit financially from installing batteries. So this has been something which is now starting to get sorted out. The next area is systems and controls. Of course, the problem is the inverter-based resources don't have inertia, and they also have very limited other active or ancillary services, which used to be standard in all synchronous generation, such as gas and coal and nuclear. So the important thing now is to try and ensure that these inverter-based generation can in fact provide the full service so that we can get a stabilized grid. And here we have issues such as faster changes affecting dynamic response, risk management, probabilistic approaches. So risk now becomes a lot more because of the generation depends so much on the weather, and then better prediction of variable generation and better management of storage. And CIGRE has done a lot of work on the predictive models relating to variable generation. So here we have information exchange, coordination, cooperation, again, between TSO and DSOs. Not only have we got inverter-based resources, they're installed at all voltages. And we also have a breakup of the industry, so it's not a vertically integrated anymore. So you've got TSOs and many DSOs. Opportunities, new software to quickly determine state of the system, dynamic and security assessment, PMU-based tools. And this is becoming more and more important now. Again, ancillary services from power electronics interface, intermittent generation, flexible consumption and storage. In other words, how are we actually going to get the synthetic inertia or other ancillary services, and how are we going to ensure that they can in fact support the grid from any disturbances. The next area, of course, is protection. And of course, we have limitations on our current, the big challenge is our current protection schemes, which are fairly set. So all the settings on the protection relays are set for a particular fault level and particular line impedance and load. Now that is changing all the time. So the impact of power electronic interface generation with decreased fault currents and increased fault currents and increased voltages and multi-earth systems now make it very difficult, in fact, for the protection that we used to have with power going in one direction to, in fact, operate. And this is really one of the challenges that we have. So what are the opportunities? Design and deployment of wide area protection systems. This is very important. Adaptive protection and automation functions for TX and DX networks. So here we're looking really at protection that can actually assess the system and alter the particular protection settings on the relays automatically to actually cater for the particular incidents. And then, of course, protection of DC networks. DC, the issue there, of course, is that you need to actually detect and trip within about 2 milliseconds. Whereas with AC systems, you can use a cycle or even more than that on MV networks. So this is really something which is an area that needs further work. Then remote setting and testing of protection and automation systems. Looking in planning, of course, in the past, planning was very uncertain anyway with the load, but the load at least was flowing in one direction or from generation to customer. Now it goes in both directions, very uncertain and very variable. So the other thing, of course, now is community awareness relating to use of stakeholders in the generation equation, which wasn't really there before. And then changing market and regulatory environment, impacts of level of central planning versus market solutions. And the CIGRE set up a study committee specifically on markets and regulations because of the impact of different market designs on the networks and how to understand that. So the opportunities, environmental effects on electricity markets. Of course, this whole environmental effects links to global warming, links to renewable energy, and then the market designs and how these actually affect the grid. And then, of course, planning of hybrid DC and AC networks. The next area you need to look at is tools. And these now are advanced numerical methods for solution of dynamic problems, advanced tools for techniques for power balancing, advanced load modeling techniques. Again, this now is, loads are now becoming very stochastic, and in fact, the load can now become a negative load, which now starts really complicating matters. So we need to have techniques to model decentralized control applications and so on. So what are the opportunities? Bridging the gap between electromagnetic transient, three-phase positive sequence simulation tools. This next point here is also very important, the hardware in the loop simulation tools. Looking at RTDS equipment is becoming more and more necessary now, because it's very difficult, in fact, to predict exactly how the hardware is, in fact, going to operate within the actual network. So research using RTDS systems is becoming something which is becoming more and more essential. Then, of course, harmonic performance of the grid with all the inverters and switching, the generation of harmonics at different points and the effect of that on the customer appliances, etc., is something which needs to be looked at. Then, of course, we need to look at the increased use of existing lines and our existing assets. So the challenges there are uprating of existing lines, replacing with high temperature conductors, conversion of AC to DC lines, which they're looking now in Germany, new insulated AC to DC submarine cables, and compact designs for offshore applications, and so on. Opportunities, increased use of interconnections, impacts on planning, operation control, establishment of electricity markets, and then again, use of overload capability, not only on underground cables, but the underground systems is one of the areas that due to this variation in the load, it is important to have robust networks that can take quite high variations in load requirements. Overhead lines, in fact, are quite resilient to that, and you can actually use real-time monitoring and other devices to actually get your overhead line thermal rating right up. But the underground cables and other devices on the system, in fact, may not be so. So that you're looking at underground systems, you're looking really at also your transformers, breakers, and so on. Then lastly is the needs for stakeholder awareness. Before, we had the stakeholder was really the customer, and then it became the prosumer or production, because you're selling energy back into the grid. Now, of course, the customer can be a integral member of the ancillary service provider. So the customer can actually provide capacity, can provide fault level, can provide voltage support, can provide harmonic damping, and a lot of other stuff, as well as demand side management. So the actual involvement of the customer, design of the market, and being able to, in fact, use the customer to the best ability is a key challenge. Here we have the big opportunity here is assessment of stakeholder participation in grid support, trading, market participation. And here again, we're looking at things such as Bitcoin or blockchain type systems, which are coming on, and how that'll affect the actual power flow within the networks. The next thing I want to, in conclusion, just to give you a little bit of a taste of what might be the next disruptor. And in CIGRE, we've set up an international work group reporting directly to the Technical Council, just looking at this kind of power to gas. And one of the big areas we're looking at power to gas could be green hydrogen, but of course power to gas could also be air, because it's a number of things. But the production of green hydrogen is produced by electrolyzers, powered by renewable energy. And this is the big area relating to green rather than black hydrogen. We could use hydrogen for storage, reconversion back to electricity, hydrogen as a feedstock with carbon dioxide to produce methane. And then the big thing here is use of transportation and rail. In other words, is the use of hydrogen fuel cells for large vehicles and rail, which are the large vehicles and trains are not really good to be powered by lithium-ion batteries, because the batteries need to be so large that the vehicles actually just transport the battery around. So the use of hydrogen there is very good. The other benefit, of course, of hydrogen is that you can restore or recharge the supply within a few minutes rather than a few hours. And also, of course, you might have seen that there is a company that has just produced a hydrogen based vehicle which can go to a super sports car, which can go up to 60 miles an hour in 2 seconds. So there's definitely a large amount of potential here within hydrogen. The challenges is the low cost of black hydrogen, which is produced at the moment through coal. However, looking at the trend and the pressure from environment on the from governments supporting green technology, I think that this challenge might be able to be removed. Then, of course, the energy that you have in methane compared to hydrogen is far higher. So they're looking at how should we transport the hydrogen, which has a fairly low calorific value compared to methane. So these are some of the challenges. But here is something which is Adam's area is looking at, which is from Siemens, which is really a e-hydrogen future network. And here we have green power making with the electrolyzers making e-hydrogen, which is either used to then regenerate through a gas turbine or fuel cells to get electrification, can be used into heat pumps together with natural gas to get you heating. It can then used in the food industry, chemical industry, agriculture, petrochemical, and then of course your mobility. This whole area here of using e-fuels either through e-cars, using hydrogen, using fuel cells, or using batteries, and then heavy trucks, aviation, and marine. Just to give you what is being considered at the moment, and this is 180 gigawatt offshore wind power in the North Sea, and there the aim there is to either generate hydrogen at this point of where the wind generator is, and then transmit hydrogen to the continent, or convert it to electrical energy, and then transport electricity across. If we get this right, you can almost have a full energy system driven completely from renewable energy. So in other words, you won't have any of the fossil fuel burning, because once you start using the hydrogen to generate electricity, you can actually get the full ancillary services. And that brings to the end of my presentation. I'd like to just acknowledge the Technical Council of CIGRE for input into this presentation, and this is my email address.
Thank you, Rob. Thank you for the excellent presentation, ranging across almost all aspects of electrical power systems in terms of the challenges and opportunities for the future. In terms of the questions, I have received a few questions. Oh, I just saw Jingyi pop up one. How does the CIGRE steering committee interact with technical council? Is there events that less experienced members can join organized by technical council?
Yes, the CIGRE steering committee has actually got the chairman of the technical council is a member of the steering committee. And every 2 years we have a combined steering committee and technical council meeting. And the aim there, that wasn't really in the past. What we did was we introduced it recently. And the reason for that was to ensure that the strategy of CIGRE is aligned to the technical direction of the technical committee. In other words, that whether they needed additional study committees or any other technical aspects that were that's required, we need a very close collaboration between the steerco and the technical committee. So yes, there is a lot of collaboration at the moment, which is definitely paying dividends.
And in terms of her second part of the question, for example, I'm an inexperienced, say, PhD students or master students, and I would like to get involved in some of the, say, working groups or the technical activities in CIGRE. Is there any suggestion from your side on how we can contribute?
That's where the national committees come in, and each national committee normally has a member from that particular country on each of the study committees. So if the person, a PhD student, is interested in communications, telecommunications, they would then find out what who the local member is, the study committee member for that particular study committee D2, and that's normally found on the websites of the national committees. That they would have that there. On the CIGRE website, you'll find the study committee D2. You'll get all the study committees. You don't have to know the names, the numbers, telecommunications, D2. You would then go there. You would then find out what working groups are active. And from there, you can actually say, well, okay, right, I need to become a member of this work group. You then apply through the study committee member in your country. They then contact the chairman of that particular work group and send your CV. And if that's acceptable, they then let you on. What we try to do with working groups, of course, you need to have members from, we don't want all the members from the UK or all the members from Europe. We want to have a very diverse membership of the working group, and you get a better output. And we really encourage young members to join the work group. So we're not too worried about numbers. Say, for example, there are 10 young members on the work group, that's fine. And normally at the end, when I lead a work group, I normally take those that contribute. We put their names onto the brochure that's produced. But we allow a great number of people to actually partake and get that networking done from the working group deliberations going forward. So definitely, I would, if you have got the opportunity, you have got an area, have a look at the CIGRE website, have a look at the National Committee NGN or National Committee website, and then try and get involved. You can be a corresponding member. And now a lot of the meetings are done on Zoom or done on GoToMeeting anyway. And then try and attend, I would say attend one physical meeting if you can. They're held normally around the world to try and get as many local people involved with the work group, because your networking is phenomenal, and your development is amazing within the working group, because you're talking to the actual experts. In my case, I did my master's on thermal rating of lines. The first working group I went into, around the table was all the professors and experts that I actually had quoted in the thesis. So you can actually meet and talk to them one-on-one, which is absolutely amazing.
Okay, thank you very much, Rob. I think we only have time for these 2 questions. And I noticed that there are additional few questions on the chat box. Can I please ask Rob you can type in briefly your answers through the chat box to those that unanswered questions during the Adam's presentation later on. Thank you. So now I would like to introduce our second keynote speaker, Adam Middleton. Adam Middleton is the chair of CIGRE UK since 2016. He was elected to the CIGRE Global Executive Steering Committee in 2019, where he coaches the Women in Engineering and NGN groups. He is the CEO of the newly formed Siemens Energy Company in the Netherlands in March 2020. The title of his presentation is The Energy Transition, COVID-19, and the Future of Our Industry. Adam, please share your screen. Thank you.
Okay, good afternoon, everybody. First question, can you see the presentation?
Yes, I can, yes.
Cool, good stuff. Ying, Indian colleagues, thank you for putting this together. Great job again. Two thank yous, first of all, to my good friend Xiaoping and friends at University of Birmingham. Thank you so much once again for your valued support. And a huge thank you, Rob, to you for your time and intervention. I just want to pay tribute coming to, I guess, the end of your tenure as the president of CIGRE globally. Really a huge thank you on behalf of the UK National Committee and all the friends for your help. Rob's, if I really remember correctly, you're the first president from Africa, and it's absolutely essential you're not the last. This is a place very close to my heart from some time I've spent there. We'll talk a little bit about development in the world going forward in the next few minutes, but just a huge thank you, Rob, for your time today and your contribution to what we do. Okay, well, for those colleagues who not met me, don't know me, I'm the slightly older one on the picture. As you can tell by my accent, I'm not Dutch, although I've had an opportunity to work in various different places in the world. What we're going to do now is talk a little bit about the energy transition, pick up a lot of the themes Rob has teased out from a technical side, but we're going to add in some new dimensions and specifically some issues around this COVID-19 problem we've got at the moment, and then think about some of the implications for our future going forward. If it's okay, what we'll do, we're going to develop some macroeconomics and talk about this new normal we hear so much about and see how this actually impacts energy transition and decarbonisation. I'm going to set you an exam question, which is COVID-19 versus the energy transition, who wins? And when we put together some closing remarks in the Q&A, I'm also going to ask you questions. So rather than having questions one way, I'm going to ask some questions back as to what you guys think, if that's okay. So our starting point is really, firstly, I hope everybody's okay. And I know COVID-19's impacted different people in different parts of the world in different ways. First thing to say, you know, I hope everybody's okay and I hope your families are okay. This is really, really important to us, yeah? This is all about change. Some people think move from normal to this new situation is scary. Some people like roller coasters. First takeaway from this is an opportunity, guys, that we're expecting the NGN to get their arms around, okay? So first thing, big opportunity. Now, global megatrends. You've seen this before. We've talked about decarbonisation, decentralisation of generation, digitalisation. Not going over that again. What I'm going to suggest is there's not 3 Ds, but probably 4.5 or 5. There's something called demand growth, and we'll talk about that just in a moment in terms of how much more electrical power we actually need. But also, we can't do these things without the 5th D, which is diversity. And we'll come back to a theme that Rob touched on a few minutes ago. So let's talk about our hypothesis around energy transition. First things first, there is still 1 billion people on our planet without proper access to energy. And if you have a look at that map on the right, there's one part of the world that looks really quite lightweight. And therefore, we've got a great deal of work to do around Africa. We've got a lot of work to do around India and other parts of the world. there are at least two strands to this. One of the strand is really around the decentralization and changing the profile. Another part is really giving people reliable power. We've got a social responsibility. So one of the themes that's previously come out in our discussions about why get involved in energy is social responsibility. We can do some really positive things for what's going on in the world. And when we talk about decarbonisation and global warming, this is the place I now live. This is the Netherlands. 1953 was a bit of a seminal time in the Netherlands because they had a bit of a flood. And if you think this is good for voters and is good for politics, it's not. There's major social unrest. The government had to do something about it and spent something like 20 billion euros building flood defences. We're going to have to do something really substantial around decarbonisation to make a difference. So let's start to put some of these themes together. So we're good engineers. We like equations. So here's the first equation. So E is the effectiveness of our solution, and this is some function of quality. Okay. Now this is too simple. We need some other dimensions. So I would say traditionally our quality of solution is down to reliability, safety, and affordability. That's my generation's view on it. But that's no longer adequate. We talked about decarbonisation as being a must. So we've got to add in this D. For our technical solutions going forward to be realistic, they have to be sustainable. Okay? Now, that's not enough, obviously. We're going to add an additional dimension. Let's think a little bit more about the flooding in the Netherlands and what actually came up if voters get upset. Everybody's got these things. The cell phones. The power of social networks today is massive. We're global, we're instantaneous. If you don't like my presentation, you're going to have messages in LinkedIn in milliseconds, okay? There are pressure groups going to act against certain technical solutions. So the A being acceptability, social acceptability is a critical factor going forward. So think about what's happened in Germany with nuclear. Nuclear has literally been taken off the network. Why? Social acceptability. Look in the Netherlands. Wind turbines on land are really not acceptable anymore. Biomass overnight in the Netherlands has moved from an important temporary solution to something that's now socially unacceptable. Overnight. And now we're seeing also objections to the large scale use of land by solar parks. This is changing really quickly. And when we talk about the effectiveness of our solutions, technically, we've got some other dimensions like the social acceptability to take into consideration. But we're now missing still a critical dimension, and that dimension is time. Now, the bad news. Energy transition is not a 100-meter Olympic sprint in 9.63 seconds. This is a marathon. This is the biggest marathon ever. And those of you who've run an Ekiden marathon, when you run it in teams or in relay, it's a lot of people, a lot of small steps over a long, long period, for up to 2030, up to 2050 and beyond. We've got a long way to go. I'm not saying we can wait, and I'm not saying we've got time. We have to start now. We have to start to address some of these wider, bigger issues now. We're going to have to work with the solutions over the next 30 years. Some solutions are going to be temporary, maybe like biomass. Some are time-bound, and whether it's technical, societal, or other reasons, we're going to lose them. They're going to be replaced. Some solutions, some innovations, they're going to be with us to 2050 and beyond. What we need is a wide portfolio of solutions, and there isn't one silver bullet. So take away from this slide the fact we need all the pieces and all the help we can get. Now, okay, that's the roadmap. But where are we trying to get to? Now, here's the image of Garden of Eden 4.0, okay? And my thanks to my colleague Leo for putting this together. There's a lot of focus at the moment on the end game, the ideal outcome, the thriving economy, the sustainable solutions, the inclusive, the prosperous world. If only we could build enough wind turbines, and there's a real great quote here, a solar farm the size of Israel, or we can cover Bulgaria in solar panels, we could get enough energy. This isn't the key point. The key point is really how we get moving forward, not the end state. We've got to start now. We've got to start what we've got to hand. We've got to work with the current energy system. We've got to work with the current industry, mobility, buildings, houses, and then we've got to add in disruptive technologies. The disruptive technologies on their own aren't enough, and they won't be able to act fast enough. The vast majority of the improvements that we'll see with energy transition are going to come from what we have now. We haven't got the time, and we certainly haven't got the money to do it any other way. Okay, so that's complicated enough. Then there's a problem. We have this elephant in the room called COVID-19. This has had a massive, massive effect on our society, economy, our lives, our health, and we use this term VUCA, volatile, uncertain, complex, ambiguous. And how you then add this into our equation, I give up the equation at this point. The energy sector has been shaken over the last 9 months significantly. There's a major rethink of some really significant old assumptions. Go and have a look at what Shell's doing at the moment. Shell is about 10 minutes that way, their headquarters. They are moving to a more sustainable business. They're now an energy company. They're not an oil company. They're an energy company moving forward. They might not have oil in their portfolio in 2050. One thing Rob mentioned is about the impact of low oil and gas price. The oil market and the gas market has just fallen over a cliff. That's going to make green solutions, green hydrogen, for example, more and more difficult from a cost point of view, and in terms of actually bringing it to market. You know, we know today that solar and wind can compete with fossil fuels on an equal basis, but something like green hydrogen made with green electrons really needs financial support, technical support to drive the innovation, to drive down the costs, so that the things like the activities of the governments and the EU funding is absolutely critically important to drive this forward. Without it, it's not going to happen quickly enough. Now, there's this great phrase, don't waste a good crisis. Now, Shell have moved in that respect to accelerate their change. And a big takeaway for us is we can use the current situation to our benefit to drive opportunity going forward. And I guess most people have seen what it's done to GDP. I think the UK figures came out last week, and there's a drop of minus 20% in the GDP numbers. And it's massive. And I guess just for completeness, I put in some of the impact on, on the stock market, and any of the colleagues on the call who've got shares will know what it's done. And also the oil and gas price. I think oil dropped well below $30 a barrel, and gas was down to 6 cents per meter cube. It's really significantly different. Now, there's a really good document that our friends at Roland Berger have put together, and I won't go through this in huge detail, but it shows actually the roller coaster we've been on through the initial shock of COVID-19 hitting, the lockdown and the world stopping, and then the ramp up, and the different countries and different regions ramping up at different rates. Now, the key issue here is, what are we doing in terms of restabilization, trying to find solutions in the way we operate, in the way we work, in order really to mitigate this second or third wave. If we got to look at our hypothesis around energy transition, I would suggest that this reset on the energy system and the energy network is, again, a great opportunity. But it's an opportunity to do something different, quicker, with what we have. Food for thought. I want to pick up another theme Rob touched upon, and the final part of the hypothesis is something around sector coupling. The basic point here is around, we talk about decarbonisation, decentralisation, digital, we talk about demand growth and diversity of solutions, and we need all the help we can get. The issue is here, we can't just look at each element stood on its own. We have to look this as an integrated system, something we call the coupling of the sectors, or sector coupling for simplicity. What we have to have is really dynamic engagement. It's not a question of bringing along a solution and expecting it to be implemented and it'll work. This is a very iterative process, and it's a very interactive process, and it requires enormous commitment by customers as we understand their demands, as the thing develops. It's an ongoing, agile, iterative process. We need a holistic view as an industry, again, pulling on one of Rob's themes, holistic view across energy, across mobility, across buildings, across industry. Electricity is a critical building block here, which is great news for us electrical engineers. But we need green molecules to act as fuel stock, feedstock, storage, and therefore we need to plan and align not only electricity networks and systems, but also gas alongside it. So our vision going forward has got to be sector coupled and joined up. We can't just look at these pieces on their own. Now, we talked a little bit about money earlier, and so just a final point here. And the good question is, can we afford decarbonisation, and can we afford the energy transition? Back in the late 80s, when I was still a student, we had something called the Berlin Wall coming down. And Germany had to reunify. And I think the value or the cost of it was 2 trillion euros. And that's a lot of money. And as a benchmark, we're going to have to be investing really significant amounts of money over a significant period of time to address the biggest challenge we have as an industry. So there are some references already there. And as Rob mentioned, as we look in terms of creating green hydrogen as being a fundamental building block, a fundamental innovation going forward, there's a new technology in terms of electrolysis coming up, gives us great opportunity to change the structure of our electrical networks, both in terms of feed and in terms of usage. One thing though, again, that's really important that Rob mentioned when we talk about the cost of oil-based hydrogen or grey hydrogen is about 2 euros per kilogram. When you have a shoot in the oil price, obviously that goes down. When you compare that to green hydrogen, the cost of the green energy, the wind, for example, at the moment is around 6 cents per kilowatt hour, and there's a roadmap to get it to about 3. And with the shoot of oil price, that really still puts a gap between where we need to be in terms of green hydrogen cost and against the traditional oil base. So we still have some work to do there, and therefore the funding we're going to get to support that is really important going forward. So just some concluding remarks. There's never been a better time, a more exciting time, or a more challenging time to be in energy. The opportunities for the generation that is in NGN are massive. Fantastic opportunities, diversity of approach, and the thing is totally dynamic. It would be such an exciting time to be 20-something years old, coming out of university, coming out with a PhD. This must be the most fantastic time to be in energy. So, takeaways. 4Ds? No, 5. We need diversity of approach, we need diversity of thought, and we need capacity to deal with not only electrons, but molecules in an integrated approach. The only way to deal with this as we look across energy, transport, buildings, industry is a coordinated approach, use what we've got, and build tomorrow's future. So the exam question is, with COVID-19, does it slow down the energy transition or does it speed it up? Lots of debate, lots of different views and lots of different elements. My view, it's probably the biggest opportunity we've got. Now, there's nothing new in the world, and there's a famous quote from a rabbi a couple of thousand years ago. If we're not going to do it now, then when are we going to do it? There's never a better time than what we have today. We've got to get on with energy transition, and we've got to get on with it now. Society demands solutions. Decarbonization's got to happen. We need diversity of thought to make it happen, and we start now. We're going to do it in an agile way, work with what we have, and develop and learn. So for the NGN, there's no shortage of challenges. there's no shortage of opportunities, and there's no shortage of change. This is quite simply the biggest challenge we've ever had. Are you guys ready? Thanks.
Thank you, Adam, for the wonderful presentation and some key inspiring questions that for all our young members from the NGN and non-young members as well. I think we have time for one question. There is one from Jingyi saying that when we are driving for renewable energy solution, are they actually greener than the conventional energy solution when considering the complete life cycle? Is there a holistic studies that can help us assure that we're definitely going towards the greener future?
It's a really good question. I know a 20-year-old student who's written a paper recently called "How Green Is My Dreamliner?" And I know it's a different industry, but in aviation, there's a lot of debate around, that the Dreamliner is the greenest aeroplane ever produced, which is great, but then you fill it full of kerosene. So yes, this whole concept of end-to-end view on the green credentials of a relative solution, sustainability and actually getting proper metrics on it is a fundamental part. So one bit of it might be super green, and the other bit might not be. So speak with data. It's a really good point. And we've got to do a better job to actually have proper metrics and KPIs to understand what the reality is. Super question.
Thank you. I think that is all we have time for. If you have additional questions, could you please send an email to us, and I will forward your questions to the speakers for them to have a time to respond. So thank you very much again, Adam, for your excellent presentation. Finally, before we finish, I would like to thank Jingyi and Professor Zhang for the opening address, and a huge thanks goes to Rob and Adam for taking the time and sharing with us your insights and on the challenges and opportunities for our energy systems. And before we close the session, can I ask everyone to take a minute to help complete the feedback form that I have just included in the chat box. The slides from all the speakers and the recording of the session will be made available to the attendees after the session. And thank you again for attending this webinar, and we will develop and we will coordinate a future event under the Birmingham Power System Young Professional Seminar Series, and I look forward to seeing you all in the future seminars. And thank you, everybody. And that's the close of the session. Thank you.